All right, so today we're really diving deep into a fascinating area. It's where neurology, anesthesiology, all that comes together in vets med. And we're going to be looking at this research paper, and it really gets into how common sedatives, the ones they use all the time, affect a dog's reflexes, specifically those spinal reflexes.
Yeah, it's such a critical area, I think, for vets because, imagine trying to figure out if a dog has a spinal injury, right?
Yeah.
And they're anxious, maybe they're in pain, they just can't stay still. How do you properly assess that? Sedation seems like the answer, but then you've got to think, well, hold on. Are those drugs now masking the very reflexes I need to see?
It's like this balancing act almost. You've got to keep them calm, but not so much that you can't see what's going on neurologically.
Yeah.
So tell me about the study itself. What were they actually looking at?
Yeah, so they took 10 healthy dogs, mixed breeds, and they tested out three different sedatives, pretty common ones, acepromazine, xylazine, and propofol. And what's really interesting is they very carefully measured these dogs' reflexes. And they did this at different times after giving the drugs, so they could track how things changed over time.
Wow, so really precise measurements to see how these sedatives were impacting the nervous system.
Exactly. And it wasn't just one or two reflexes. They looked at a whole range of them. Everything from the patellar reflex, that classic knee-jerk thing, you've probably seen it, to more, I guess, complex reflexes like the pelvic limb withdrawal reflex. Basically, seeing how a dog pulls its leg away from something.
And these different reflexes kind of give you a window into how well, the nervous system is working as a whole.
Absolutely, yeah. And here's where it gets interesting. You'd think, right, that a sedative it would just dampen down all the reflexes. But what they found is it's not that straightforward. In fact, some of the sedatives actually seem to make some reflexes stronger.
Oh, wow. Okay, now that is interesting. That's not at all what I would have expected. So let's
hmm
break that down. Let's start with espapromazine. What did they observe with that one?
Yeah, so with the acepromazine, they noticed that it seemed to make the patellar reflex, that knee-jerk one, it made it more pronounced. It's like the sedation, in a way, made it easier to get a really clear, strong knee-jerk response.
Oh, wow. So instead of making the reflex less obvious, it almost amplified it. Why would that be?
Yeah, it's the million-dollar question, right? The researchers think it might be because acepromazine, it also has this muscle relaxant effect.
hmm
So by relaxing the muscles throughout the dog's body, it might actually make that specific reflex stand out more, if that makes sense.
Yeah, less overall tension, more pronounced reflex.
Mhm.
Okay, that's fascinating. And I imagine that's really valuable for vets, right? Because, if a dog's anxious or tense to begin with, those subtle reflexes might be easy to miss.
Exactly, yeah. So acepromazine could be a real game changer for these exams because it helps vets get a clearer picture of what's happening neurologically even when the dog's sedated.
Okay. Acepromazine,
Okay.
possible game changer. What about xylazine? How did that drug compare?
So xylazine, it was interesting. It seemed to have this effect on the cranial tibial reflex. That's the one you see when you tap the hock. That one seemed to be enhanced by the xylazine.
Okay, so again, with the enhanced reflexes instead of just being suppressed.
Yeah.
Is it that muscle relaxation element again? Is that what we think might be going on?
Yeah, that's the thought. That's the working theory, at least. Although it's worth noting, in this study, xylazine didn't seem to impact the patellar reflex the same way acepromazine did, even at a standard dose. So there's definitely some nuance there that needs more digging into.
So much nuance. Dosage, specific reflexes, different drugs. This is complicated. All right, we got acepromazine, we got xylazine. What about propofol? What did they find with that one?
Okay, yeah. So propofol is where things get even more interesting. So it did what you might expect with some of the reflexes, actually. It seemed to dampen them down, particularly the extensor carpi radialis, that's the one in the wrist, and the pelvic limb withdrawal. But, and this is important, the patellar reflex, that knee-jerk one again, and the thoracic limb withdrawal, those stayed pretty much the same.
Okay, so propofol is throwing us a curveball here. It's not just this uniform, oh, everything's suppressed, which I'm guessing had some pretty big implications if a vet's trying to decide on their sedation protocol, right?
You got it. They can't just assume, oh, sedation equals suppressed reflexes across the board. Like with propofol, maybe using a lower dose, just a sedative dose instead of a full-on anesthetic dose, might be better for these neurological exams.
To make sure those key reflexes are still there, you can still assess them. Now, you mentioned earlier this whole thing about monosynaptic versus polysynaptic reflexes. How did that factor into the findings with the propofol?
Oh, yeah, good point. So it all comes down to how complex the neural pathway is. A monosynaptic reflex, like that patellar knee-jerk one, so it's a direct line, sensory neuron to motor neuron, bam, reflex.
Nice and simple, I like it. So then polysynaptic.
Polysynaptic, think of it like a relay race. There's multiple handoffs happening. The signal's going through multiple synapses, so it's a much more complex pathway. Pelvic limb withdrawal, that's a good example of that.
Okay, so different levels of complexity, and it sounds like propofol was kind of reacting differently based on that.
It seems like it, yeah. It looks like propofol might be better at inhibiting those polysynaptic reflexes, more complex ones, compared to those simple monosynaptic ones.
So more likely to kind of knock down those reflexes that require a whole chain reaction of signals to happen. I bet researchers are really interested in figuring out exactly how that works with propofol.
Absolutely, yeah. It opens up a whole new area of research trying to understand the exact mechanisms behind it.
Okay, so we're seeing all these little quirks, right? Each of these sedatives, how they're interacting with the nervous system, even down to the specific reflex being tested. For vets, this has got to be really useful information
Oh, for sure. Gives them a much better idea of what they're working with when they're choosing sedation for a patient who might have a neurological issue. For instance, if they really need to see that patellar reflex clearly, they might actually choose acepromazine because they know it could actually make that response more obvious.
So instead of avoiding sedation, they're kind of choosing strategically. Interesting. What about if they're really interested in those polysynaptic reflexes, like that withdrawal reflex we were talking about?
In that case, they'd be extra careful with propofol, especially at higher doses, because they know it has the potential to suppress those responses, and they don't want to miss anything important.
This is really making me realize there's so much more to sedation than I ever thought about. It's not just about calming the dog down. It's about understanding all these subtle ways these drugs are interacting with the nervous system, the very thing you're trying to examine.
Exactly, and that's what makes this research so important. It reminds us that even those procedures that seem simple on the surface, they often have these layers of complexity we need to be aware of.
Now, this particular study, they were looking at these three sedatives in isolation. But in a real-world situation, vets often use combinations of drugs. What happens then?
Oh, that's a great question. And it's actually a really important area for more research. This study, it's a great foundation, but we really need to understand how these drugs behave when you start mixing them.
Because those interactions could be significant, right?
Oh, absolutely. Their effects could be additive, they could cancel each other out. It's like a whole other level of complexity to unravel.
We're peeling back the layers of the onion here, and there's always another layer, right?
Perfect analogy. That's what makes this whole field so fascinating. Always more to learn, always more to investigate.
And always more to learn about how to take the best care of our canine friends. Speaking of which, this study also looked at the panniculus reflex, just in case anyone listening is not familiar. That's the one where the skin twitches when you kind of stimulate the dog's back. What did they observe about that one?
So with that panniculus reflex, they found that both acepromazine and xylazine really decreased it in the dogs.
Huh. Interesting. So two different sedatives, but both leading to kind of a reduced response for that specific reflex.
Exactly. And, that doesn't necessarily mean something's wrong. It's just really important information for vets to have in their back pocket when they're looking at the whole picture of a neurological exam.
Because a diminished panniculus reflex in this case might not actually be a neurological problem, right? It could just be that sedative doing its thing.
Exactly. It all comes back to, like we were saying, really understanding these drugs, how they can affect things. That's why research like this is so important.
For sure. And it also makes you realize how important all those other parts of the exam are, too. Taking a good history, doing that hands-on physical exam.
Couldn't agree more. The more pieces of the puzzle a vet has, the better. Helps them get to the bottom of what's going on, figure out the best way to help that dog.
It's like they're like detectives in a way. But instead of solving crimes, they're solving these medical mysteries. And this study, it's like giving them a whole new set of tools to do that.
I like that analogy. And every good detective needs those reliable tools, right? And the information to back them up. This research, it's doing just that, helping us understand how sedation really affects the nervous system, all those little details.
And when it comes down to it, that means better care for our dogs, which is what matters most. So if anyone out there's thinking, whoa, this is a lot, just remember, something as seemingly simple as giving a dog a sedative, it's actually way more complicated than it seems.
Absolutely. And that complexity, that's what makes it so important to keep talking about, keep researching, keep learning everything we can about veterinary medicine.
Well said. And on that note of continuous learning, I think we're going to wrap up this deep dive. Hopefully everyone listening enjoyed this little journey into the world of canine neurology, anesthesiology, all that good stuff.
Yeah, who knows? Maybe it sparked some curiosity out there. There's always something new to discover in this field, that's for sure.